Alright, so today in Algebra 2, we're going to look at section 5.3, our last section before our first test. Okay, so we're going to do day 1 today, graphing radical functions. Our central question, how can you use what you know about transformations of functions to graph radical functions? So after today, you should be able to graph and transform a radical function. We're going to only look at graphing square root and cube root functions. Okay, so we're going to graph, state the domain and range of each function, and tell if the function is increasing or decreasing. Okay, remember that if it is an even root, okay, so even root, no negative underneath the radical, right? So no negative under the radical. So we're going to look at f of x equals the square root of 3x. Let's just make as an xy table. So xy, so I can pick like 0. I'm going to pick 3, 12, and let's say x is 27. So those are the x's that we're going to start out picking. Okay. So I'm just going to plug them in to find my y's. So 3 times 0 is 0, the square root of 0 is 0. 3 times 3 is 9, the square root of 9 is 3. So I picked x's to make this a perfect square root. So 3 times 12 is 36, the square root of 36 is 6. 3 times 27 is 81. The square root of 81 is 9. So I can plot these points. So 0, 0. Over 3, up 3 for 3, 3. 12, 6. Be a little off my graph. 27, 9 is going to be way off my graph. Okay, so it's going to look like this. Okay? So my domain, these are my x's. Remember, I cannot have any negatives underneath my radical. So in interval notation, I would say bracket 0 to infinity, or that's the same thing as saying x greater than or equal to 0. My range, my y values, my smallest y value is 0. So again, my range would be 0 to infinity, or y greater than or equal to 0. So now, is this graph increasing or decreasing? Okay, so what's happening to the graph from left to right? As the x's get bigger, the y's get bigger. So as x gets bigger, y gets bigger as well. So this is increasing. So the graph is increasing. Okay. So the second one we're going to look at is a cube root. Okay. So again, I want to make an xy table. This time I can have negatives underneath my radical because I can take the cube root of a negative number. So I have 2 times x. Okay. So I know negative 8 is a perfect cube. So I could have negative 4, 0, and let's say positive 4. I plug these in. 2 times negative 4 is negative 8. The cube root of negative 8 is negative 2. I plug in 0. 2 times 0 is 0. The cube root of 0 is 0. 4 times 2 is 8. The cube root of 8 is positive 2. Plot these points. Again, 0, 0 over 4, 2. Negative 4, negative 2. The cube root is going to look kind of like a sideways S, like long, stretched out S length on its side. That 0, 0 is the turning point. The domain, notice that I can have positives and negatives, so my domain is negative infinity to infinity, or I can say that's all real numbers. That's our notation for all reals. The range, again, any of my y's, negative infinity to infinity. Again, all reals. Increasing, decreasing. So from left to right, right? So from left, it's going up. My x's and my y's are getting bigger. So again, I am increasing. Okay. Okay. So let's look at some more of these. So number 3, f of x equals the square root of x minus 5. So I'm going to make my xy table. It's the square root, so I know that I cannot have any negative numbers underneath my radical. So the very first x value that I could have would be 0, but I have minus 5. So if I put 0 minus 5, I'm at the square root of negative 5. So I need to find what x value would make this 0. So 5 minus 5 would get me 0. And again, I'm going to try to make perfect squares, right? My next perfect square I know is 1. So what minus 5 would get me 1? That would be 6. So I'm going to pick 6 for my x value. Then my next perfect square is 4. So what can I subtract from 5 to get 4? That's going to be 9. So now I'm going to plug these in. 5 minus 5 is 0. Square root of 0 is 0. 6 minus 5 is 1. Square root of 1 is 1. 9 minus 5 is 4. Square root of 4 is 2. Plot these points. So 1, 2, 3, 4, 5, 0. 6, 1, 9, 2. So there's my graph, my domain. So this time, where's my x value starting? I'm starting at 5. So in interval notation would be bracket 5 to infinity, or x has to be greater than or equal to 5. My range, my lowest y value is 0. So again, 0 to infinity, or y greater than or equal to 0. Increasing or decreasing, this again from left to right is getting bigger, so increasing. So now we're going to look at a cube root. So we want to graph g of x equals the cube root of x plus 1. Again, I want to pick x values where I know that's going to be a perfect cube. We said we knew that like negative 1 is a perfect cube. So what do I have to add to positive 1 to get negative 1? That's going to be negative 2. I know that 0 is a perfect cube, so negative 1 would get me 0 in there. I know positive 1 is a perfect cube, so what do I have to add to 1 to get 1? 0. I could keep going, right? My next perfect cube I know is 8, so what do I have to add to 1 to get 8? 7. So you get the picture of what we're doing. So now plug these in. Negative 2 plus 1 is negative 1. The cube root of negative 1 is negative 1. Negative 1 plus 1 is 0. The cube root of 0 is 0. 0 plus 1 is 1. Cube root of 1 is 1. 7 plus 1 is 8. Cube root of 8, 2. Plot these points. Negative 2, negative 1. Negative 1, 0. 0, 1. 7, 2. And again, I know it's like the S laying on its side, stretched out. My domain, okay, I can plug in any number for x I want, so that's negative infinity to infinity, or all reals. Same thing with my range, right? If I can plug any number in, I can get any number back. So my cube roots, I'm always going to have negative infinity to infinity. From left to right, we are increasing. So on these, we've had to play these games of what number do I have to plug in to get a perfect cube or a perfect square root. If we graph using our transformations, our parent function, then we don't have to play that guessing game. So we're going to review graph using the transformations. Right? So the parent function of a radical function looks like f of x equals the nth root of x. All of our transformations, exactly like what we've had before. Okay, that a out in front. So a times the nth root of x minus h, all of that plus k. Okay. The a determines whether it's a vertical stretch or compression. Remember that the absolute value, okay, so if the absolute value is between 0 and 1, it's a vertical compression this time with radicals. Okay. If the absolute value of a is greater than 1, it is going to be a vertical stretch. And remember, if it's a vertical stretch, then it's also a horizontal compression. If it's a vertical compression, it's also a horizontal stretch. Right, that h value, again, determines horizontal translations. That moves it left or right. A plus h shifts left. A minus h shifts right. So remember, those are just always the opposite. That k determines the vertical translation, up or down. Plus k goes up, minus k goes down. Now, the domain will be affected by the h, right? So domain is affected by h. Along with the, you also have to remember a negative a would give us a reflection. The range is affected by k. Okay? So let's talk about what our parent functions are going to be. So let's list our parent functions here. So again, we're just dealing with the square root and the cube root. So if we look at the parent function, y equals the square root of x. The xy table that we will always use will be 0, 1, 4, 9. Square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9, 3. If we are looking at cubed root, our parent function is y equals the cube root of x. Our xy table will be negative 8, negative 1, 0, 1, and 8. The cube root of negative 8 is negative 2, cube root of negative 1, negative 1, cube root of 0, 0, cube root of 1 is 1, cube root of 8 is 2. So these are the parent functions that we want to remember, right? So let's graph using the transformations, and we're going to state our domain and range, and then we can also talk about increasing or decreasing. So number one, I have g of x equals 2 times x plus 3, all of that plus 5. So I see that I've got a vertical stretch, right, by 2. The plus 3, so I'm going to go left 3 plus 5 up 5. We can go ahead and talk about domain and range right now. Okay, the x plus 3, since it moves at left 3, our parent function started at 0, 0, so now my domain got shifted to the left 3, so my domain is negative 3 to infinity, or x is greater than or equal negative 3. The range, okay, I'm still looking at my k value, so the original graph got shifted up 5, so my lowest y value is going to be 5, so 5 to infinity, or y greater than or equal to 5. So remember, our parent xy table, you're always going to list your parent. So we're looking at 0, 1, 4, 9. 0, 1, 2, 3. So then my new xy table, it said x plus 3, that always comes out opposite, so x minus 3. I had this 2, so I'm going to do 2y plus 5. So all of my x values, I'm going to subtract 3. So I'm going to get negative 3, negative 2, 1, and 6. 2y plus 5. So 2 times 0 is 0. 0 plus 5 is 5. 2 times 1 is 2. 2 plus 5, 7. 2 times 2 is 4. 4 plus 5, 9. 2 times 3 is 6. 6 plus 5, 11. This is what we're going to graph. So we're going to go over negative 3 up 5. Over negative 2 up 7. Over 1 up 9. Over 6 up 11 would be off our graph. So it's going to look something like that. From left to right, I can see this is increasing again. Right, let's do another one of these. Notice that that was so much easier than to try to play the game of what x value would I have to plug in to make perfect squares there. Okay, so that's why we do the transformations. So number 2, we've got g of x equals 1/2 the square root of x minus 1, all of that minus 3. So again, that 1/2, so this time we see it's going to be a vertical compression by 1/2, minus 1, so we're going right 1, minus 3, we're going down 3. So in my domain, this time my domain is shifted to the right 1, so 1 to infinity, or x greater than or equal to 1. The range, it went down 3, so -3 to infinity, or y greater than or equal to -3. My parent function, so our parent xy, again, I'm 0, 1, 4, and 9, 0, 1, 2, and 3. My new one, x minus 1, so that comes in my table as x plus 1. I'm going to do 1/2 y minus 3. So we're going to add 1 to all of our x's. So 0 plus 1 gets us 1, 2, 5, and 10. 1/2 times 0 is 0. 0 minus 3, -3. 1/2 times 1 is 1/2. 1/2 minus 3 is -2.5. 2 times 1/2 is 1. 1 minus 3, -2. 1/2 times 3 is 3/2. 3/2 minus 2 is -1.5. So that's what we want to graph. So over 1 down 3. Over 2 down 2.5. Over 5 down 2. So it's 2.5 right there. Over 10 down 1.5. So our graph, something like this. And again, I can see that it is increasing again. In order to graph cube roots using the transformations, we would do the exact same thing. We would just use our parent function, xy table, as the -8, -1, 0, 1, and 8 for our x's. Okay. All right, so that's where we're going to stop at for day 1, okay, of graphing the transformations. Okay, and we're going to graph these using our transformations. Our homework is going to be the 5-3 worksheet. We're going to just do 17 through 21. So you've got 6 that you're actually going to graph. I want you to graph those on your own graph paper. Okay, so please use graph paper. Write down both parent XY tables and the new XY tables. So that's day 1 of section 5.3.